Integral 1 into dx is nothing but what? X. From the limit, what you are going to apply? 0 to pi by 2. So therefore, which implies 2i will be is equal to pi by 2 minus 0. Properties of the integrals a to b f of x dx can be splitted as a to c f of x dx plus c to b f of x dx. 2 to 5 means you can have here lesser than 5. Which is a function lesser than 5? 2 to 5, 2 is lesser than 5, upper limit is only the 5, so lesser than 5 only you should take it. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have learnt many problems of definite integrals, isn't it? That too especially by substitution method. And in today's session, dear students, here we are having session number 22, which is nothing but chapter number 7 called integrals. And then here we are going to have a 7.11 exercise problems. Now, without any delay, let us move on to the problems of that here, which is nothing but integral 0 to pi by 2 sine to the power of 3 pi 2 x into dx divided by sine to the power of 3 by 2x plus cos to the power of 3 by 2 into x. So many of them will be cancelling this sine to the power of 3 by 2x and sine to the power of 3 by 2x, which is wrong method, okay? So what are you going to do here? We are going to call this one as let it be is equals to I. Let the given problem is equals to I. Okay, and then you know already according to the properties of the integral 0 to a f of x dx can be changed as 0 to a f of a minus x into dx. Now thinking, what is this a? A is nothing but the limit whatever they have given, 0 to pi by 2. Pi by 2 is nothing but a here. So therefore, accordingly, changing the given integral as like that. So it will be giving you, that is integral 0 to pi by 2. You can change sine to the power of 3 by 2, x can be changed as pi by 2 minus x, okay. So I am calling this equation as 1 and then changing this one, I am going to call that equation as 2. That here, sine to the power of 3 by 2, pi by 2 minus x, okay, plus cos to the power of 3 by 2, pi by 2 minus x, changing x as a minus x. A is nothing but pi by 2 here into dx. Now, call this equation as 2. Now, you can have adding the equation 1 and 2. You are going to get the right hand side. That is, I will be is equals to 0 to pi by 2 sine to the power of 3 by 2 divided by cos to the power of 3 by 2 x plus sine to the power of 3 by 2 x, right, into dx. Now dear students, you can observe here sine, whatever the power is there, but sine of 90 minus theta is what? Cos theta. So what it will become? So you can change this as equation 2, 0 to pi by 2 as sine 90 minus theta is cos theta, cos to the power of 3 by 2 theta divided by, again here sine of 90 minus theta is again cos theta. So cos to the power of 3 by 2 x, again cos 90 minus theta is nothing but sine theta, sine to the power of 3 by 2 into x into dx. So let us take this equation as 2. So this is the equation 1. Adding that equation 1 and 2, we are getting plus 0 to pi by 2 into, so we are having here cos to the power of 3 by 2 into x divided by here cos to the power of 3 by 2 x plus sine to the power of 3 by 2 x, right, into dx. Now adding the equation 1 and 2, here also I, therefore this is also I. So left hand side will become what? I plus I, isn't it? So I plus I is equal to the same thing you are going to get it as, which is 2I is equal to integral 0 to pi by 2. Let us take the LCM will be this, that is cos to the power of 3 by 2x plus sine to the power of 3 by 2x, and here we can add the numerator directly since LCM is same, plus cos to the power of 3 by 2 x into dx. Now dear students, this will get cancelled. So 2I will be is equal to integral 0 to pi by 2 1 into dx. So therefore you can implies that, so 2I will be is equal to, now integral 1 into dx is nothing but what? X. From the limit what you are going to apply? 0 to pi by 2. So therefore which implies 2I will be is equal to pi by 2 minus 0, because you are going to apply first upper limit and then minus you are going to apply the lower limit. Now pi by 2 minus 0 is nothing but pi by 2 itself. So 2I is equal to pi by 2. Otherwise you can have the answer transferring 2 to the right hand side. I will be giving you the value pi by 4. And this is your final answer. You are going to get it as dear students. I hope you understood this problem how to solve. Let us look into the next problem. Yes, 0 to pi by 2 cos to the power of 5 x into dx divided by sin to the power of 5x plus cos to the power of 5x. Same like in the last problem, let me call this one as letter I is equals to. So calling this equation as 1, okay. Now therefore I will be is equal to, now according to the property of the integral, we can change it as 0 to a f of x dx as 0 to a f of a minus x dx. So therefore changing accordingly, you can have this one 0 to pi by 2 cos to the power of 5. So because you are changing x as a minus x divided by sin to the power of 5 a minus x plus cos to the power of 5 a minus x. Same like you are going to have dear students, which implies that, so I will be is equal to 0 to pi by 2. You know already cos to the power of cos of 90 minus theta is sin theta. So sin to the power of 5x divided by sin 90 minus theta is cos theta plus cos 90 minus theta is sin theta, right? Now adding, I am going to call this equation as 2. Adding equation 1 plus 2, you are going to get equation 1 plus 2. So you are having left hand side is nothing but I plus I will be is equal to 0 to pi by 2. You are having cos to the power of 5x divided by sin to the power of 5x plus cos to the power of 5x into dx plus 0 to pi by 2. This is sin to the power of 5x divided by sin to the power of 5x plus cos to the power of 5x into dx. Now the LCM will be same. You can now take the integral as same. I plus I will become 2I. So the numerator, denominator I can take it as sin to the power of 5x plus cos to the power of 5x. Numerator you can add up these two, that is sin to the power of 5x plus cos to the power of 5x, isn't it, into dx. Now this will get cancelled. So 2I will be is equal to integral 0 to pi by 2 1 into dx. Now which implies that 2I will be is equal to integral 1 into dx is x from the limit 0 to pi by 2. Apply the upper limit and the lower limit. You are getting 2I will be is equal to pi by 2 minus 0, which is pi by 2 only. If you want I am writing, otherwise 2I will be is equal to pi by 2. You can cross multiply 2. So I will be is equal to pi by 2 into 2, which is nothing but pi by 4. So this type of problems you can add it directly by taking a property of 0 to a f of x as 0 to a f of a minus x into dx. I hope you understood this problem. Now let us move on to the next one, what they have asked. Integral minus 5 to 5 modulus of x plus 2 into dx. ds. You have to know what do you mean by the modulus function. Let me write it here. Modulus of x is defined as x, positive x, if x is greater than or equal to 0, okay, and then minus x if x is lesser than 0. So this you have to know. So similarly, you can take this modulus of x plus 2 can be defined as, so x plus 2, that is positive x plus 2, if x plus 2 is greater than 0, which implies that x is greater than minus 2. This you understood, I think, so taking plus 2 to that side. Now minus of x plus 2, because negative of x plus 2, if x plus 2 is lesser than 0, otherwise you can have x is lesser than minus 2, isn't it? So this is what you have to know it, dear students. According to this, you can split up So minus 5 to plus 5 in between, you can take the limit as a minus 2. So according to the properties of the integrals, a to b f of x dx can be splitted as a to c f of x dx plus c to b f of x dx. That's it. Okay. So therefore, accordingly, you can write minus 5 to 5 modulus of x plus 2 can be splitted into modulus of x plus 2 into dx can be splitted into minus 5 to minus 2 modulus of x plus 2. Afterwards, let us substitute what is that, plus integral minus 2 to 5 modulus of x plus 2 into dx. I hope you understood this one. Now here, modulus of x plus 2 minus 5 to 2. Minus 5 to 2 means x should be what? A lesser than minus 2. You are getting the function x is lesser than minus 2 here. X is lesser than minus 2 is nothing but minus of x plus 2, isn't it? So therefore, you can have here integral minus 5 to minus 2. Modulus of x plus 2 will become minus of x plus 2 into dx plus here minus 2 to 5. Minus 2 to 5 means it is a positive. So x should be greater than minus 2, which is a function x is greater than minus 2. So x is greater than minus 2 is x plus 2. So x plus 2 into dx. Okay. I hope you understood this one, how to write down the function according to the limit. Okay. So and then you are having integration of this directly. Integration of x is nothing but x squared by 2. So therefore, let me integrate x squared divided by 2 again. So plus 2 into dx. 2 is a constant. 2 into 1 dx integration is 2x. So plus 2x from the limit what? From the limit minus 5 to minus 2. Right? And then plus same you are going to integrate here. Integral of x into dx is nothing but, be careful dear students, minus sign is there. So minus sign I have written. I have not written, I am writing the minus sign, minus of this one. Okay. So next you are having plus, see, x integral is nothing but x square divided by 2 plus 2 integral is nothing but 2x from the limit only for this one, right? From the limit minus 2 to 5. Now apply the upper limit for this first and then apply the lower limit. That's it. So applying the upper limit you are having, which implies that minus of upper limit is minus 2 squared divided by 2 plus 2 into minus 2, right? Again, lower limit will be minus into another minus for the lower limit, which is plus. So minus into minus is plus. You can have minus 5 whole square divided by 2 plus 2 into minus 5. You understood this one, I think. Now applying the upper limit for this one, plus 5 square divided by 2 plus 2 into 5, correct? Again minus lower limit applying. So you are having minus 2 whole square divided by 2 plus 2 into minus 2. Now close the bracket here. Again you can solve this one, which implies minus 2 minus. So of minus 2 whole squared is 4. 4 by 2 is nothing but 2. Again 2 into minus 2 is nothing but minus 4, right? So plus again here. So 5 squared is nothing but 25 divided by 2 minus 2 5s are 10, right? Again 5 squared is nothing but 25 divided by 2 plus 2 5s is nothing but 10. Again minus, you can simplify this, 2 squared divided by 2 is nothing but what you are having, 4 by 2. 4 by 2 is again 2. So 2 minus 4, 2 2s are 4. Therefore, now you can simplify this one, which implies 2 minus 4 is nothing but minus 2. Minus 2 into minus is nothing but plus 2, right? So here 25 by 2 plus 25 by 2. Here minus 10 plus 10 will get cancelled. So 25 by 2 will become what? 50 divided by 2, isn't it? 2 will be the LCM. 25 plus 25 is 50. Again here 2 minus 4 is nothing but minus 2. Minus into minus, which would become plus 2. So plus 2. So the answer you are going to get 2 plus 2 is nothing but 4. So 4 plus 50 divided by 2. 50 divided by 2 is nothing but, you can add up this one, 2 4s are 8. So 8 plus 50, that is nothing but 58 divided by 2, right? Otherwise, you can have 2 1s are, which is nothing but 2 2s are 4, again 19, which 18, which is 2 9s are 18, isn't it? Which is nothing but 29. This is your final answer, dear students. We'll move on to the next problem what they've asked. Integral 2 to 8 modulus of x minus 5 into dx. Same we are moving according to the modulus definition. Let me write this one. Modulus of x minus 5 will become, see, x minus 5, positive of that one, when x is, that is, if you can write, if x minus 5 is greater than 0, which implies that x should be greater than 5. Similarly, minus of x minus 5, which implies you can write it as, if you multiply minus sign inside, this will become negative and minus 5 will become positive, which I can write it as 5 minus x. I hope you understood this one. Minus into plus is minus, minus into minus is plus. Okay. So, if what the condition? If x minus 5 is lesser than 0, isn't it? Or you can write, which implies that x should be lesser than plus 5. So, this is what the condition you can have. Therefore, between 2 to 8, you can take up the limit as 5 in between. According to the property of the, again, the integral a to b f of x dx can be splitted as a to c f of x dx plus c to b f of x dx. Now, here you can write it this one, integral 2 to 8 modulus of x minus 5 into dx can be 2 to 5. Integral of 2 to 8 modulus of x minus 5 into dx can be splitted into integral 2 to 5 modulus of x minus 5 into dx plus integral 5 to 8. So, modulus of x minus 5 into dx. Now, what happens here? So, 2 to 5. 2 to 5 means you can have here lesser than 5. Which is a function lesser than 5? 2 to 5. 2 is lesser than 5. Upper limit is only the 5. So, lesser than 5 only you should take it. So, lesser than 5. So, this is a function. So, therefore, which is nothing but 5 minus x. I can write, so integral 2 to 5 modulus of the x minus 5 will become 5 minus x into dx plus integral 5 to 8. 5 to 8 means upper limit is nothing but 8, lower limit is 5. So, greater than 5. So, greater than 5, this is a function you are having. So, x minus 5 into dx. Okay, now you can integrate easily. 5 into dx integration is nothing but 5x. So, therefore, which implies 5 into x minus x integration is nothing but x square divided by 2. From the limit, you can apply 2 to 5 plus, you can have x dx. See, x into dx integral is nothing but x square divided by 2. Again, minus 5 into dx integral is minus 5x from the limit 5 to 8. Okay. Now, you can apply the limit. First, applying 5 to the whole term. So, which will become 5 into 5 minus 5 square divided by 2. Similarly, minus, open the bracket, applying the lower limit 5 into 2 minus 2 square divided by 2. Now, again here also applying the upper limit 8 first. So, 8 square divided by 2 minus 5 into 8, isn't it? Again, you are having minus, open the bracket, applying the lower limit, that is 5 square divided by 2 minus 5 into 5. Now, let us simplify this further, which implies 5 into 5 is nothing but 25 minus 25 divided by 2 minus, see here, 5 into 2 is nothing but 10, isn't it? 2 squared, 1, 2 will get cancelled. So, you are having 2. So, 10 minus 2, which is nothing but 8. So, minus 8, plus into minus is nothing but minus 8 you are having. I hope you understood this one. Plus 8 squared is nothing but 64 divided by 2 minus 5 into 8. 8 5s are 40. Again, let us simplify this one. 5 5s are 25. 25 divided by 2 minus 5 5s are 25. So, you are going to get it as, let us multiply minus n inside. 5 5s are 25 divided by 2. Again, minus into minus is plus 25. Okay. I hope you understood this one. Now, you can have, see, so 25 plus 25 is nothing but 50. Again, here you can cancel this one. 2 1s are 2 3s are 6, 2 2s are 4, isn't it? So, therefore, you can add up, which is nothing but 25 plus 25 is nothing but 50. So, 50. Again, we'll go for the, what is that? Integer, which is minus 8 plus here minus 40 plus 32. Minus 40 plus 32 is nothing but minus 8. Minus 8 is nothing but minus 16. So minus 16. Again, remaining is only this one. 25 by 2 and minus 25 by 2, which is minus 50 divided by 2. I hope you understood this one. Now 50 minus 16 gives you 34. 34 plus 16 is 50, isn't it? So 34 minus 50 divided by 2. Otherwise, you can have 50 by 2 is nothing but 25. So 34 minus 25 gives you the answer 9. And this is your final answer you can have for this problem, dear students. I hope you understood what is the procedure of a modulus of the function. Now we'll be moving on to the next problem, dear. What they've asked: integral 0 to 1 x into 1 minus x to the power of n into dx. Now, dear students, here let me take according to the property of 0 to a f of x dx can be as 0 to a f of a minus x into dx. Now here f of a minus x, a is nothing but here 1. So changing the limit as well. Let me call this one as let I is equals to, okay, let I is equal to. If I call let I is equal to, this will become, so I call this equation as 1, okay. So I am going to call that equation as 1. Now I will be is equal to 0 to 1, x will become 1 minus x because a is nothing but 1 here. So 1 minus x. Now here you can have x will become 1 minus x. So therefore you can have 1 minus x will be 1 minus x whole to the power of n, right, into dx. So this will be implies that 0 to 1, 1 minus x. Again, see, if you multiply 1 minus into plus is minus 1, minus into minus is plus x to the power of n into dx. Now minus 1 plus 1 will get cancelled. So remaining is nothing but you can have 0 to 1. See, 1 minus x as it is I am writing 1 minus x, okay, that is I is equal to into, see here, x to the power of n. X to the power of n into dx. Now I will be is equal to 0 to 1. You can multiply x power n inside. 1 into x power n is x power n minus x power 1 into x power n into dx. Now you can segregate this 0 to 1 x to the power of n minus x to the power of n plus 1 into dx. Now what happens to this? You know, integral of x power n is nothing but x to the power of n plus 1 divided by n plus 1. Similarly, you can do this one. X to the power of n plus 1 plus 1. N is nothing but n plus 1. Remember, dear students, divided by n plus 1. Okay, from the limit what? From the limit 0 to 1. Let us simplify that further. X to the power of n plus 1 divided by n plus 1 minus x to the power of n plus 1 is plus 2, n plus 2 from the limit 0 to 1. Now apply the limit. Upper limit will be applied 1 to the power of n plus 1 divided by n plus 1 minus 1 to the power of n plus 2 divided by n plus 2. Again, minus, you can apply 0 to the power of anything will be 0 minus 0 to the power of anything will be 0. Now you can simplify this one. 1 to the power of anything will be 1 itself. So which implies that 1 divided by n plus 1 minus 1 divided by n plus 2. You can cross multiply, which will be giving you n plus 1 into n plus 2, right? So you can cross multiply, which will be giving you n plus 1 into n plus 2. So cross multiply n plus 2 minus n minus 1, right, which implies, so here plus n minus n will get cancelled. 2 minus 1 is 1 divided by n plus 1 into n plus 2. And this is your final answer. You are going to get it for this question, dear students. I hope you understood this one, how to solve the problem of that 1 minus x to the power of whole n when it is given, right? So next problem they have given it is 0 to pi by 4 log 1 plus tan x into dx. Now here let me call this equation as let I is equal to, okay. So therefore according to the property 0 to a f of x into dx, I can change it as 0 to a f of a minus x into dx. What is a here? A is nothing but pi by 4. So therefore, let me change accordingly. I is equal to, before that I am going to call this equation as 1. So integral 0 to pi by 4 log of 1 plus tan pi by 4 minus x. Why? Because changing x as a minus x, right? Into dx. Now what this will become? This will become, you can have tan pi by 4 minus x is nothing but what? Tan a minus b, right? Which is nothing but tan a. So tan of a minus b is tan a minus tan b divided by 1 plus tan a into tan b. Now which implies tan pi by 4 is 1 minus tan x divided by 1 plus tan pi by 4 is 1. 1 into tan x is nothing but tan x. Therefore, I can simplify this as tan pi by 4 minus x will become integral 0 to pi by 2 log of 1 plus, this is 1 minus tan x divided by 1 plus tan x into dx. If you want, you can take the LCM here. So I will be is equal to 0 to pi by 4 log of, see, taking the LCM as 1 plus tan x into 1 is 1 plus tan x, right? Plus 1 minus tan x divided by 1 plus tan x into dx. Now, you can cancel plus tan x minus tan x. 1 plus 1 will become 2. So, therefore, you can write this one as integral 0 to pi by 4, 2 divided by 1 plus tan x into dx. Now, I am going to call this equation as 2. After calling this equation as 2, adding equation 1 and 2. So, therefore, add equation 1 plus 2, what it will be giving you? So, it will be giving you I plus I will become 2I, 0 to pi by 4. So, log of 1 plus tan x plus 0 to pi by 4 log of, sorry, log I forgot here, log of, because why? I am having here log, is okay, log of 2 divided by 1 plus tan x. Now you can combine the limit, dear students. By combining, I plus I will become 2I will be is equal to 0 to pi by 4. So log of 1 plus tan x plus log of 2 divided by 1 plus tan x, right? So this is according to log m plus log n. Log m plus log n is nothing but log m into n. So accordingly, we can write this one, 2I is equal to 0 to pi by 4 log m into n, 1 plus tan x into dx. Now here 1 plus tan x will get cancelled. Remaining is 2I will be is equal to 0 to pi by 4 log of 2, isn't it? So into dx, anyway log 2 is a constant, you can bring outside. 2I is equal to log 2 into integral of 0 to pi by 4 1 into dx. Now 2I will be is equal to log 2 into 1 into dx. Integral is x from the limit 0 to pi by 4. So therefore, don't cancel this 2 and this 2. So 2I will be is equal to log 2 has a value. So integral, that is pi by 4 minus 0, which is nothing but pi by 4. Otherwise, you can have 2I will be is equal to log 2 into pi by 4 minus 0 is pi by 4. You can cross multiply 2. I will be is equal to log 2. 4 will be multiplied with 2, which is nothing but log 2 into pi by 8. And this is your final answer. You are going to get it as dear students. I hope you understood this step, how to solve the problems. Okay. Now we'll be moving on to the next one, integral 0 to 2 x into under the root of 2 minus x. Same we are, by using the first property we are going like 0 to a f of x dx can be written as 0 to a f of a minus x into dx. So therefore, I am going to call this equation as let I is equal to, so therefore, I will be is equal to 0 to 2, a is nothing but 2, so x minus 2, which is nothing but 2 minus, x is nothing but 2 minus x, under the root of 2 minus x is nothing but 2 minus x into dx. So therefore, I will be is equal to 0 to 2, 2 minus x into under the root of multiply minus sign inside, minus into plus is minus, minus into minus is plus into dx. These two will get cancelled. So which implies 0 to 2, which is equal to 0 to 2, 2 minus x under the root x, right, into dx. Now, what is under the root x? Under the root x is x to the power of 1 by 2. So therefore, you can have 0 to 2. So left hand side you are having high 2 minus x, x to the power of 1 by 2 into dx. Multiply inside. So 0 to 2, 2 into x to the power of 1 by 2 minus, here x to the power of 1 is there, base is same, you can add up the powers. So x to the power of 1 plus 1 by 2, which is nothing but 3 by 2 into dx. So which implies 0 to 2, 2 into x to the power of 1 by 2 minus x to the power of 3 by 2, taking the LCM as 2. 2 ones are 2, 2 plus 1 is nothing but 3, 3 by 2 you are going to get it as. So integrating this here, so 2 is a constant I can write. So this is like x to the power of n, which is x to the power of n plus 1 divided by n plus 1, correct? So minus, again this is also x to the power of n plus 1 divided by n plus 1. So from the limit 0 to 2. Now further simplification here, 2 into, you can have x to the power of, what is that? Here you can apply the limit 2 to the power of 1 by 2 plus 1, correct, divided by 1 by 2 plus 1 minus 2 to the power of 3 by 2 plus 1 divided by 3 by 2 plus 1 minus 0. So 0 power anything will be 0, 0 divided by anything will be 0 itself, right? So therefore, by simplifying this, it will be giving you 2 into 2 to the power of 1 by 2, which you can write it as 2 to the power of 1 by 2 into 2 divided by, here 1 by 2 plus 1 is nothing but 3 by 2. So minus, again 2 to the power of 3 by 2 into 2 divided by 3 by 2 plus 1 is nothing but 5 by 2. Now further simplification gives you 2 into 2 is nothing but 4. So 2 to the power of, again you are having root 2. Again this will become 3 by 2 will go to the numerator, 2 divided by 3. See, this 2 will go to the numerator, right? So 2 by 3 minus, again this 2 will go to the numerator. 2 to the power of 3 by 2 can be written as 1 by 2 plus 1. 2 into 2, this 2 will become 4 divided by 5. Now you can take out 4 common factor. If you take out 4 common factor, remaining is 2 root 2 divided by 3 minus, you can have here 2 to the power of 1 by 2 is root 2 into 4 I have taken already out 5, correct? So here 2 also can be taken outside. So 8 will become, so root 2 divided by 3 minus root 2 divided by 5. Further simplification gives you the answer 8 into, so you can take the LCM as is nothing but 15. So here it will become 5 root 2 minus here 3 root 2. So the answer 8 divided by 15 into 5 root 2 minus 3 root 2 is nothing but 2 root 2, right? So 2 root 2. So again you can multiply, 8 2s are 16. So 16 root 2 divided by 15. And this is your final answer. You are going to get it for this question, dear students. Now I hope you understood this, how to solve the problem and how to apply the limit, dear students. Dear students, I hope you understood this session of a definite integral of the exercise 7.11. In the next session, we'll be moving on to some more solving the problems of exercise 7.11. So thank you, dear students. Keep watching. Have a nice day.